Hi everyone, welcome back to Linux. Today we are going to solve about LeetCode problem number 2095, that is delete the middle node of any linked list. First let us understand the problem. They have been given a head of the linked list. We need to delete the middle node in that linked list and return the head of the modified linked list. The middle node of a linked list of size n is n by 12th node. Okay, and from the start and zero based indexing, and this symbol square brackets denotes that largest integer lesser than or equal to x. For example, the linked list size is 6, then we take divide by 2, that is 3. Here we can see the largest integer actually and lesser than or equal to x. The 3 is in a integer. Okay, so we just return here it is 3 is in an output. For example, if you take n equal to 5, linked list size equal to 5, then you will have to 5 divided by 2, that is 2.5. Here the 2.5 it's not an integer, so we take 2 because this is in a largest integer lesser than or equal to x. We can't take 3, then it should be in a greater than x. Okay, so the output is 3. It's actually normal division. We neglect the decimals. And for better understanding, we go for an example. They have been given sample linked list of a size 7. So in this linked list we need to delete the middle node, right? So there is left side 3 and right side 3, and we just remove 7 and return the linked list. As you can see, there is no 7 in this output. For better understanding, we go for an even size linked list, that is 1 2 3 4. Okay, here the size is 4, right? So our formula will be 4 divided by 2, that is 2th node. We need to delete the 2th node from the zero based indexing. So in this case we need to delete the 3rd node, node 3. So the output will be 1 2 4. This is the output. So we need to perform these operations. Okay, I have one approach. Let's explain. Let me explain. Since they given a head of the linked list, what I can do was I just find out the length of the linked list. If I know the length of the linked list, then I can easily find the middle node, right? So if I found out the linked list, that is n, I can just put n equal to 2, and normally the decimal points have been removed. Then n it will be lesser than or equal to x, that is in a middle number, and just go to in a while loop and up to n by 2th position, then remove that index. Okay, this is a better approach, not an optimal approach. I first code it out and then I will explain the better approach, optimal approach. Why is my internet not working? Okay, scam. So I don't know the length of the linked list, right? I just initialize with 1 and current equal to 8, so I don't want lose my 8 pointer. what it will do was, it just from this position it will go to this position, and I just increment n plus equal to 1. I just increase the size as the current as a value. Once the while loop is finished, n holds the length of the linked list. What I can do was x equal to n double slash by 2. This will remove the decimal points and gives the largest integer that is lesser than or equal to x. And what I can do was, I just iterate again in from the head. I just current equal to head while c not less or maybe I is lesser than x. I just initialize I equal to 0. Current equal to current dot next. For understanding, I just print here which node it will stop. Print current dot val. Okay, I just run this. Let's see the output. It's exactly start at the node 7. Here you can see here node is 3 needed to be removed. It's exactly stop at the node 3. It's all we need to remove 1, and it's also exactly stop at 1. You can see, like, if you want to remove the 7th node, we don't want a pointer here. We don't want a pointer here. We need a pointer from the 4th, because the 4th node only having a pointer of 7th. Okay, so we want to remove the 7th pointer in the 4th node, okay, and map it to the 1st node. That's how it will work. So what we can do was, we just maybe we can put -1 here. Now it will be pointing to the 4th node, and we just current equal to current dot next. What it will do was, from this position the next pointer should be not this 7th one, the next to the 7th, that is 1. So we just return it. It should work. Oh, something going on. Let's see. 1 3 4 7, nothing is changing, right? Current equal to current dot, oh sorry, current dot next. Now it has to work. Yeah, it works fine, and I just comment it out. I just submit. Oh, where is this error? Line number 20 here. Oh, okay, we have a base case, like if it dot next will be null. If it dot next is none, we just return none. I think this is the case. Or also, if it is also none, we have to return none, right? Or it is none. Now it has to work. Yeah, you can see it's submitted. Let's analyze the time complexity and space complexity. In this code, we are using 2 loops, right? That is, time complexity will be big O of n for finding the length of the linked list, and big O of n by 2 for finding the middle node, right? So when they're computing time complexity, they usually remove these constants. So the overall time complexity will be big O of n, and space complexity will be big O of 1. We can't, because we don't use any variables to store any intermediate result, right? So this is the better approach, but as you can see here, we are using two loops. Okay, we are using two loops, one to find the length of the linked list, other to find the middle node. What I can say, we can find the middle node in single iteration. That is an optimal approach. Let's erase this out. Let's take an example 1, that is 1 3 4 7 1 2 6. What I can do was, I have a 2 pointer, slow pointer, fast pointer. Initially both are pointing to a current here. In each iteration, the slow will move one step and fast will move 2 steps, okay, in each step. So in next iteration, slow will go here and fast will be here. In next iteration, the fast will be here and slow will be here, right? In next iteration, the slow will be on the 7th node and fast will become 8th node. This is the current position now. As you can see, just because one pointer moving double the speed of slow pointer, so it will reach the end. As you can see, in next iteration it will be null, so we can't proceed with that. So as you can see, slow will always pointing to a middle element. For better understanding, we can go for another example too. As usual, the slow and fast will be point here. In first iteration, slow will go here and fast will be here. In next iteration, slow came here and fast go here. That is null. Actually, that is null. And here also, as you can see, the slow is pointing to a middle element. So we just want to remove this. But to remove this pointer, we needed this pointer, right? Because tooth next only stores the third node, right? Third node pointers. So what we can do was, in the tooth next we will store fourth pointer. So the third pointer is automatically blocked or automatically unreachable. So in one iteration, we can, using two variables, we can find the middle node and we just update that. Let's write the code. We don't want n and anything. Why it's not? I just confirm. Actually, we need a base case, right? So if it is none or a dot next is none, we just want to return none. And slow equal to 8, fast equal to 8. So while fast and fast dot next, it will check whether the fast is null or does it contain object. If it will contain any object, it will go into the loop. If not, it will come out the loop. So we just move slow to one step, slow dot next, and fast to double step, fast dot next dot next. After these iterations, the slow will exactly point once again. Oh, another submission. The slow is exactly point at the 7th node, right? So we don't want the 7th node point. We want one node previous to that. So I just declare the variable previous equal to slow, and before updating slow, I just store that node into previous. Okay, in that way I can get the 4th node, right? Because it will in the last iteration only it will go to 7th. So before iteration it will be 4. So what I can do was previous dot next equal to previous dot next, and I just return it. It has to work. Let's see. Yeah, it worked. Let's submit that. Yeah, it's submitted. It is this is an optimal approach in this problem, and that's it. Let's see on next.